Hello everyone. Good afternoon all of you. Am I clearly audible to all of you? Just confirm, is my voice clearly audible to everyone? Hello everyone. Welcome. Good afternoon. Welcome to the session. Just confirm, give a thumbs up. Is my voice clearly audible to everyone? Yes or no? Alright. Okay, so today's topic with us is factorials in number system. So we'll go through this topic in brief, like what is the basic of factorial, and then maybe see a few questions and rules that come under this section. Now, as such, it's a big area which cannot be covered in 30 minutes, but the objective of this session is to give you a brief idea of what this topic is all about. And if I see the numbers, the section numbers in detail, it is one of the 5 areas in quantitative aptitude, and people often tend to find this section a bit difficult. Okay, sometimes people feel that numbers area is a bit difficult and they skip this chapter. The reason of difficulty, if I have to mention, then it is the application of those concepts. If you pick any chapter, the rule is very simple, but the way it is applied, that scope is huge, and that is why questions of different kinds are asked from this area. So for a candidate who is reading numbers, or as such any chapter that comes under the section numbers, so it is absolutely necessary for you to understand how the concepts are applied. Okay, and the more the number of questions you solve, the better are your chances of getting the question solved in the exam. Okay, don't think that I'll just read a chapter and solve 10-15 questions and I'm done for it. You have to keep pushing yourself, try new questions, see if there is a new question, there is a new logic, try and adapt it. Okay, to see that how that same concept that you had learned is applied in that question, and then keep adding it to your repository in your memory. It's not like I'm not asking you to mug up the concepts or the questions also, but the approach in how many different ways can I ask a question from one particular chapter. That is what every candidate must understand. Okay, welcome all of you. Welcome to the session. Good afternoon. Do like the class, all of you. Hit the like button and subscribe to the Unacademy CAT-alyst channel, so you keep getting lots of videos like this on this channel every day. And keep subscribing this channel, and ask your friends also who are preparing for CAT 2021 to subscribe to this channel. Lots of useful content you can find over here. Okay, so to begin with, today's topic is factorials in number system. So first thing, before we start, this is just a brief introduction of me. I'm an MBA and a mechanical engineer, and I have close to 4 years of teaching experience in CAT for the exam CAT and other management entrance tests. I've been giving the exam myself since the last 4 years, and you can see I've scored 4 times 99 percentile plus in the quantitative aptitude section. These are my recent CAT 2020 scores. The reason I'm showing this is because not long back I was a student like you people, and I was preparing the way you are preparing right now. So I know how it's done and what it takes to prepare for an exam like this. Okay, so in all my sessions I try and convey the same message that I received as a student. The questions that I practiced, the way I practiced, I try and share the same thing with you people, so that you can benefit in the same way that I did. You can find my profile on the Unacademy app and follow me over there to get access to my classes. And this is Unacademy Iconic CAT 2021. If you want to take a subscription on Academy, you can consider this. You get benefits like a personal mentor, test analysis and reports, preparation for other management and test tests. Hello everyone. Welcome to the session, and these are the Unacademy CAT 2020 results. You might have seen we show the results in every session, because that's the best way to keep someone motivated for like the preparation. Okay, so to begin with, first let us understand what do we mean by this term factorial. Okay, you might have heard about factors, but what is factorial? So if I'm writing n factorial, I can define it as the product of first n natural numbers. Okay, n factorial is the product of first n natural numbers. So like you can see, starting from 1, natural numbers, they start with 1. So starting from 1, you go till n and multiply every natural number. Okay, so 1 into 2 into 3 till n. That is the meaning of n factorial. Product of first n natural numbers. So to start with, 0 factorial, we take it as 1. Okay, and 1 factorial is 1. If I come to 2 factorial, you can see I have written 1 into 2, 2 factorial is 2. 3 factorial, 1 into 2 into 3, 3 factorial is 6. Then 4 factorial 1 into 2 into 3 into 4. 4 factorial is 24. 5 factorial 1 into 2 into 3 into 4 into 5 into 6. Sorry, there's a typing mistake. 5 factorial is still 5, and then 6 factorial is still 6, and so on. Okay, if I'm taking till n factorial, so it's still the number n. Okay, 5 factorial will be till 5. This is a typing error. Just a second. Alright. So 5 factorial is 120, 6 factorial is 720. So you get the basic idea of what factorial is. If I am taking till n factorial, it's the product of first n natural numbers. Now, if I take any one factorial, let us say I take 5 factorial. Okay, 5 factorial, can I write it as 5 into 4 factorial? Because 1 into 2 into 3 into 4, that gives me a total 4 factorial and then 5. So 5 factorial can be written as 5 into 4 factorial. Similarly, it can be written as 5 into 4 into 3 factorial, because 1 into 2 into 3 is 3 factorial. So based on that principle, I have written here that n factorial can be expanded as n into n minus 1 factorial. So same logic, n minus 1 factorial can be written as, Jobin, I'm coming to this. How is 0 factorial 1? So look at this that I have written under the note section. N factorial is n into n minus 1 factorial. Okay. So here if I am taking, just a second. Let me write this for you. How is 0 factorial 1? It's a very good question asked by Nobin. Alright. Yeah. So is it visible to you guys? Just look at this. He asked how is 0 factorial 1. So if you look at this, is the screen clearly visible, guys, or is there a lag? Yeah, so look at this, Jovin, that I say that n factorial is n into n minus 1 factorial. So I can write 1 factorial is 1 into 1 minus 1 factorial. So 1 factorial is 1 into 0 factorial. So by that logic, I get 0 factorial is 1. Is making sense now? Euler's theorem is not for this session. I'll take it up in another session. Euler's theorem, your Euler's torsion function, actually belongs to the part remainders. Okay, so in this session we'll only focus on factorial part, because just a 30-minute session we can't take Euler's here, but I'll definitely take a session on Euler's, don't worry. It's part of remainders. Okay, Euler's and Euler's torsion function is part of remainders and co-prime numbers. Euler's torsion function is used to calculate co-prime numbers. I'll definitely take a session on that, don't worry. Okay, but I hope this question is answered. How is 0 factorial 1? Okay, 1 factorial is 1 into 1 minus 1 factorial. Going by the logic, n factorial is n into n minus 1 factorial. So by that I get 0 factorial is 1. Now for convenience of calculation, you need to remember from 0 factorial till 8 factorial if possible, or else till 6 factorial is also enough. After that, if anything is needed in the question, you will go ahead and calculate. But for convenience of calculation, like for faster calculations, you just need to remember around 5, 6, 7 factorial if possible. Okay. And remember this expansion of n factorial. N factorial is n into n minus 1 factorial. Okay, hope this is making sense. Please feel free to ask question. I'll definitely take your question, Ranganath. Euler's theorem. Next session I'll try and arrange a question class on Euler's. Don't worry. Okay. Now next thing is on what concept is this factorial based. we'll introduce a term called as IGP, index of the greatest power, IGP. What do you mean by IGP? It's defined as the highest power of any number present in a factorial. Okay, highest power of any number present in a factorial, that is called as IGP. For example, look at this. I have written 6 factorial. It's the product of 1 till 6, first 6 natural numbers. So when I write 1 into 2 into 3 into 4 into 5 into 6, if I try and make the prime factorization of this, okay, if I try and prime factorize 6 factorial, now till 6 factorial I see there are only 3 prime numbers, 2, 3 and 5. Now how many 2's are there? How many 2's are there? If you count, is it making sense that there will be 4 2's? There is a 2 in 2, there are 2 2's in 4, and there is a 2 in 6. So in total I have 4 2's, so 2 to the power 4. I'll have 2 3's, one is present in a 3 and then another 3 is present in 6. So I'll have 2 3's and then I'll have 1 5. So 2 to the power 4 into 3 square into 5 to the power 1. This is the prime factorization of 6 factorial. Now if I ask what is the hash power of 2 present in 6 factorial, you can clearly say that hash power of 2 present in 6 factorial is 4. Thus the IGP of 2 in 6 factorial is 4. This is the meaning of IGP. Okay, hash power of any number present in any factorial, that's the meaning of IGP. Okay. Similarly, if I say what's the IGP of 3 in 6 factorial, you can say IGP of 3 in 6 factorial is 2, because there are 2 3's present in 6 factorial. Okay. And how to calculate this? Not always we will go ahead and prime factorize. 6 factorial was still a smaller number. What if the number is a big number like 100 factorial or 200 factorial? We cannot write and prime factorize it. So we'll follow this factorization technique like just like we do for prime factorization. 6 you divide it by 2. Okay, if I are trying to find the IGP of 2, you divide it by 2. So you can see the way I have done 2, then 3, and then 2, then 1, and then add the quotients 3 plus 1. Excluding the number, you just add the quotients. You can see I have put it under the circle. You just add the quotients in there. Okay, I hope it's making sense. Any number, if you want to find the IGP, you divide it by that particular prime number. But remember this, that this method is only applicable for prime numbers. You cannot apply it for any other number. Okay, this method is only applicable for prime numbers. So if you are trying to find the IGP of 2 in 6 factorial, you simply divide 6 by 2 in the way that I have shown, and then add the quotients except 6. Okay, except the number, you add the remaining quotients. Okay, and remember this, that this process is only applicable for prime numbers. Then I have written in the note, like this is like a property, you can note it down, that IGP of any prime number p cannot be p ever in any factorial. Suppose I will say which factorial will have IGP of 5 as 5, there is no such number. IGP of 5 can never be 5. Okay, or in other words, there is no factorial which will have exactly 5 5's. It will have 4 5's, it can have 6 5's, but there is no factorial which will have exactly 5 5's. Okay, I hope it's making sense. Is it making sense? Just give a thumbs up. Am I clear on this concept, IGP? Did you follow what IGP is? Highest power of any number present in a factorial, that's called as IGP. And remember that the IGP of any prime number can never be p. Like IGP of 5 cannot be 5, IGP of 7 cannot be 7, IGP of 11 cannot be 11, IGP of any prime number, it cannot be that prime number itself. Okay, so let's say I am talking about IGP of 7. IGP of 7 can be 6 and it can be 8, but it can never be 7. Okay. Let's see one more example. Let us say I take the number 100 and we'll try and calculate the IGP of 2 and 3 in it. So just look at the way I have calculated the IGP of 2 in 100 factorial. So if you want to calculate the IGP of 2 in 100 factorial, you simply divide 100 factorial by 2. Okay, you simply divide 100 factorial by 2. So as you can see, I have just gone with the continuous division, taking the quotients only. Ignore the remainders if you are getting any, just take the quotients. Then 250, 225, 212, 26, 23, 21. I have done this, and then I added all the quotients except the number 100. It's a very simple process to calculate IGP, absolutely easy. Okay, any factorial, if you want to calculate the IGP of the prime number, divide that factorial by the prime number. Okay, so if you add, you see the IGP of 2 in 100 factorial, I am getting it as 97. Similarly, if I want to calculate for 3, IGP of 3 in 100 factorial, again similar process, divide 100 by 3. And you get the IGP of 3 in 100 factorial is 48. Okay, so as I said, this method is only applicable for prime numbers. But what if you are asked to find the IGP of a composite number? Is it not possible to calculate? We cannot calculate using this process, but there is definitely a way to calculate the IGP of composite numbers. So for an example, if I say that let us say the IGP of 6, I want to calculate the IGP of 6 in 100 factorial. So how do I calculate it? So I've written to like take the IGP of composite numbers. You need to break the composite number into their prime factors. So for example, when I say IGP of 6, you don't look at the number 6 as 6, you look at it as 2 and a 3. How else will you get a 6? To get a 6, I need to multiply a 2 and a 3. That means if I take 1 2 and 1 3, I can get 1 6. Okay? Now if I look at this in 100 factorial, I have 97 2's and I have 48 3's. So how many 6 can I make? It's like think of it in this way: there are 100 people, but there are only 50 caps. So how many people can wear the cap? Only 50 people. Doesn't matter how many extra people you have. The number of caps is what is the limiter in this. Okay, even if I have 100 people, but because there are only 50 caps, so 50 people can only wear the cap. So it's a similar logic. There are the number of 2's is bigger. 97 2's I have, but the number of 3's is just 48. So to get a 6, I need a 2 and a 3. So with 48 3's, I can take 48 2's and I can make 48 6. And the remaining extra 2's, it's of no use, because only with 2 I cannot make a 6. I need a 3. So the number of 3's basically decide the number of 6 here. So the IGP of 6 will be 48. Is it making sense how to calculate the IGP of composite numbers? Are all of you clear on this one? Just give a thumbs up. Is this making sense? Yes or no? IGP of a composite number. I said that you cannot calculate the IGP of composite number using this prime factorization method, but we can calculate the composite number IGP using this process. That you break the composite number into prime factors and then see each of the prime factors what is their individual IGP and then decide what can be the IGP of that number. Okay, I cannot do anything with those extra tools that I have. So suppose this is the first time you are solving this question, but the next time someone is asking you find the IGP of 6, think yourself, do we actually need to calculate the number of 2's? Logically the number of 2's is obviously going to be more, because every second number is a multiple of 2, so you will get 2's more frequently. So anyways the IGP of 2 is going to be more. So why calculate it? Because the IGP of 3 is going to decide. Whichever is less, that is going to decide. So next time you see a question like this, no need to waste time on calculating the IGP of 2. First time to understand, you calculate both. But henceforth when you see, just go with the IGP of 3. Okay. I hope it's making sense. Alright. Keep asking questions in the meantime. Any doubts you have, feel free to ask questions. Okay. Same 100 factorial. The question on IGP can be put in yet another way. That is, you'll see this term being used a lot of times, called as number of trailing zeros. Okay, number of trailing zeros in any number is basically the number of zeros at the end. Suppose I say you a number 52,000. 52,000. What is the number of trailing zeros? The number of trailing zeros will be 3, because 52 and then at the end you have 3 zeros. So trailing means towards the end. Number of trailing zeros means the number of zeros that you can find in the end of a number. That's the meaning of number of trailing zeros. So basically number of trailing zeros indicate the number of tens in that number. And a 10 is a composite number, which means to get a 10, I need a 2 and a 5. Following the similar logic, if the number of 2's is going to be higher anyways, so number of trailing zeros is decided by the IGP of 5. In any question you see it's talking about number of trailing zeros, understand that we are only going to deal with IGP of 5. Every time you see trailing zeros, it means IGP of 5. Because 0 means you have to multiply it by 10, and number of 10s means number of 5's, because number of 2's anyways is going to be higher. I hope it's making sense to everyone. Okay, IGP of 5. Every time it's talking about number of trailing zeros, go for IGP of 5. Now look at this 100 factorial. I calculated IGP of 5, 520, then 54. So number of trailing zeros is 24. So if you write down 100 factorial, if you really multiply all those numbers and find the end number, you will see towards the end there will be 24 zeros. That's the meaning of trailing zeros. Now just like IGP of 6 in the previous case, in the same question, if I say what is the IGP of 48? 48 is yet another prime number. How do I find the IGP of 48? Now look at this. IGP of 2 we had already calculated in the previous slide. IGP of 2 was 97. So if I have 97 2's, how many 16 can I make? 2 to the power 4 is a 16. So if I have 97 2's, how many 16 can I make? I can make 24 16's. Because to get a 16, I need 4 2's. So take 4 2's and group them together, you will get a 16. So how many such groups can I make? I can make 24 such groups. Alright. Similarly, IGP of 3 is 48. So to get a 48, I need a 16 and a 3. So I can have 24 16s and I have 48 3's. So now this case is reversed. Number of 16 is less, number of 3's is extra. So I take a 16 and a 3 and make a 48. I can take 24 16s and with 24 3's I can get 24 48. But the extra 3's that you have, it's of no use because along with 3, like 3 alone can't give you 48. So always the lesser IGP is the decider here. Okay. So although people can ask 2 has the like higher IGP, why did I go with 3? In when the power of each of them is 1, you go with the lesser one. But unlike this question where it is 48, तो यहाँ पे 2 to the power 4 हो जाता है. 2 to the power 4 means I have to take 4 2's. So number of 2's is greater than the number of 3's. But number of 16's will be greater than number of 3's. That's not a guarantee. Okay, so you have to check with the number. Alright, I hope it's making sense to everyone. Yes or no? Is this making sense? Let's give a thumbs up. Are all of you getting clarity on what IGP is basically? Nothing difficult in it. It's an easy concept, very easy concept, factorial. Maybe questions can be difficult, but concept wise factorial is a very easy concept. We'll do a few questions after this so you'll get a clarity of how this is applied in questions. So let us take a look at this one. Take a look at this question. 1500 factorial is 209 to the power x into y, where y is not a multiple of 11. Then find the value of x. Okay. This is given. 1500 factorial is 209 to the power x into y, where y is not a multiple of 11. Now, why did this question talk about multiple of 11? So, if y is not a multiple of 11, the first thing that I'll try and find is how many 11s are present in 1500 factorial. 1500 factorial, it will obviously have 11s, yes or no? It will definitely have 11s, 1500 factorial. First, let us calculate how many 11s are present in 1500 factorial, and then we'll figure out x and y का क्या value आएगा. That's the secondary part. Let us first figure out how many 11s are present in 1500 factorial. Okay, let's see this. When I write 1500 factorial, I try and calculate the IGP of 11. So I can see the calculation IGP of 11 is 149. You divide 1500 by 11 and follow the process of calculating IGP. You get that the IGP of 11 is 149. That means there are 149 11s present in 1500 factorial. So if in the LHS you have 149 11s, in the RHS also I will have the same number of 11s. Okay, RHS has two terms now, 209 to the power x and y. It is saying that y doesn't have any 11 at all. So all the 11s must be present in 209 in that case. Because anyhow you have to balance LHS and RHS. In the LHS if there is 149 11, in the RHS also you need to have 149 11s. And given that y is not a multiple of 11, that means you cannot have any 11 in y. So every 11 is present in this term 209 to the power x. Now if I take 209 once, I will get 111. So if there are 149 11s, that means 209 to the power 149. Wow. That means x is 149. Making sense? Is this making sense to all of you? Yes or no? Very easy question, just provided the way you look at it. Okay, as such the question is not difficult. Question is easy. Just the way you look at it. We are dealing with IGP of 11 because the question specified that y is not the multiple of 11. So that's your clue. You have to start with 11 and check how many 11s are present in the LHS. Okay. Hope it's making sense everyone. Just give a thumbs up. This question clear or not? And those of you who are joining, do like the session and subscribe to the Unacademy CAT-alyst channel. You keep getting regular videos like this throughout the day. We have sessions, so go through all the sessions. It's very useful. Any topic you are thinking that I might need assistance in, that you'll definitely see the classes of that topic in this channel. Okay, so definitely subscribe and ask your friends who are also preparing for CAT-21 to subscribe to the channel. Alright, let's look at the second question. What is the remainder when 35 factorial is divided by 37? Okay, what is the remainder when 35 factorial is divided by 37? This is the question. So there is a theorem called as Wilson's theorem. Okay, theorem called as Wilson's theorem, which says that for any prime number p, the remainder of p minus 1 factorial divided by p is p minus 1. This is Wilson's theorem, where p is a prime number. So for example, 36 factorial divided by 37 would have been 36 directly from the theorem. P minus 1 factorial divided by p, the remainder is p minus 1. So 36 factorial divided by 37, the remainder would have been 36 directly by applying Wilson's theorem. Similarly, 16 factorial divided by 17 is also 16 directly applying Wilson's theorem. Okay, but now if I see this question is asking about 35 factorial and not 36 factorial. Welcome all of you. Correct, yes, Anurag, correct. So what, how we are deriving this? 36 factorial, I can write it as 36 into 35 factorial. Now 36 divided by 37, you can see the remainder is 36, and 35 factorial divided by 37 is what you want to find. So let that be x. So I can easily see there's a equation 36 equal to 36, x is equal to 1. Okay, so this is like extended Wilson's. So from this result, I can conclude that p minus 2 factorial divided by p, the remainder is always 1. Okay, Wilson's theorem talked about p minus 1 factorial divided by p, it is p minus 1. But from this, I can derive p minus 2 factorial divided by p is 1. I can also derive for p minus 3, p minus 4. So when we take up remainders, I'll show you what is the formula for p minus 3 factorial, p minus 4 factorial also. So they have also got the formulas, but the main theorem is p minus 1 factorial divided by p is p minus 1, the remainder. From this, the others, like other extensions are derived. Hope it's making sense, everyone. Just give a thumbs up. Is this clear or not? Very basic question. Okay, nothing difficult. I hope it's clear to all of you. Let's take a look at the third question. I think this should be easy. Find the number of zeros at the end of 220 factorial. 220 factorial, I have to find the number of zeros. So basically, question is asking find the number of trailing zeros. Number of trailing zeros means IGP of 5. So simple question, just find the IGP of 5 in this number. So this is how it's done. IGP of 5 in 220 factorial, divide 220 by 5. So the IGP is 53. Pretty basic. Okay. Those of you are starting your preparation right now, start with questions like this, easy questions. Be fundamentally strong. Okay, don't worry about CAT level, CAT question. Be fundamentally strong first, and then you'll see automatically you'll be able to solve all the questions. Don't worry too much. Okay. And because this was just a 30-minute session, I try to show you as much things as possible. But there are more things to it. We'll take up gradually in the coming sessions. Yes, correct, Andrea, correct. Let us see this one. Question number 4. A is the product of first 200 multiples of 2 and B is the product of first 10 multiples of 5. Then find the number of trailing zeros at the end of AB. Find the number of trailing zeros at the end of AB. Okay, A is the product of first 200 multiples of 2 and B is the product of first 10 multiples of 5. Find the number of trailing zeros at the end of A by B. Okay. So how will we calculate this? Any answers? Any answers on this? Okay, let us see this. When I write A as the first 200 multiples of 2, so I'll start with 2 into 4 into 6 into 8 till 400. These are the first 200 multiples of 2. So there are 200 terms, each of them has a 2, so I can take 2 to the power 200 as common. Correct, very good, correct. So I can take 2 to the power 200 as common and I get 200 factorial. Now if I calculate the number of trailing zeros in A, so I have to calculate IGP of 5 in 200 factorial, which I get as 49. That means there are 49 zeros at the end of A, or 49 5s in A. Similarly, B is the product of first 10 multiples of 5. So B is 5 into 10 into 15 till 50. So each term has a 5. I can take 5 to the power 10 common. So 5 to the power 10 into 10 factorial. So the IGP of 5 is 5 to the power 10. Already I have 10 5s. And the number of 5s in 10 factorial. Now 10 factorial has got 2 5s. So total there are 12 5s in B and 49 5s in A. So when we are taking the ratio A by B, so number of 5s will be divided. So 5 to the power 49. And in the denominator you have 5 to the power 12. So overall you will have 49 minus 12, 37 5s. These are the kind of questions that are asked from this area. I hope it's making sense to everyone. Please give a thumbs up. Have you understood this or not? This question, is it clear to all of you? Yes or no? Is this clear to everyone? Just give a thumbs up. Is this question clear to all of you or not? Okay. So these are a few batches coming up. You can use my invite code that's live to join in these batches. Okay, and if you use the code, you can get a discount on your subscription. Then there's this offer for CAT 2021 subscription. Okay, you buy a 6-month subscription today and you get 1 month extra. And this is a feature Ask a Doubt in the Unacademy app where you can just post your doubt and someone from our side will answer your question. And then this is an academic combat. It's a weekly scholarship test, so do go ahead and appear the scholarship test every Sunday at 12 noon. This is conducted. You can use my invite code DASLive to register in it for free. Okay, no registration fees. Just go ahead and give the exam. If you do well, you really get very good discounts on your subscription prices. So that is it for this session. This is a homework or an assignment I have for you. So please try and solve this question and do write your answers in the comment section. Okay, do write your answers in the comment section. Find the sum of the number of zeros and the number of 6 at the end of this. Just a second, just a second. Yeah, so this is the assignment. So do complete the assignment, and once you find the answer to this question, do write the answer in the comment section. Okay, so that is it for this session, guys. Hope you liked the class. Do like and subscribe to the Unacademy CAT-alyst channel, and have a nice day. See you guys in the next session. Thank you.